Today's lesson, and the final lesson of the course, is about financial applications. And what I'm going to do is I'm going to combine 4 and 5 into a single one. And I'm really not going to follow this too closely. We'll do the questions, but I'm not really interested in the way that the questions are being done here. I think I want to show you a different way of doing them. We have the benefit of enjoying, since we can use technology without any limit for this semester. So if you're talking about your CPT, for this section, if you could describe to me how to use the technology to solve these questions, that's just as good. You don't need to, I'll obviously share with you the formulas and that, but to me, this is a particularly good type of math where technology really helps us. It lets us focus on what we are doing and understanding what we are doing, as opposed to getting bogged down in the formulas and the steps and the calculations. So anyway, let's leave it at that for now. Interest is the idea that let's just start a new page here. I'm just gonna open this up. You can take some of this down if you think it's important. Interest. Interest is the idea that money has a time value. Money has a time value. That is to say that money today is worth more than the same sum tomorrow, right? So $100 today or $100 tomorrow are not actually the same amount of money, right? And this is where the concept of TVM, which is the time value of money, is related to interest and how money compounds over time. So this is some examples of this, right? If you invest $5,000 in a stock today, you might collect, $6,000 in the future. Unless you're me, of course, and then you will collect far less than the $5,000 you put in. But don't let that discourage you. It's still a very smart idea. Just not when I do it. When you buy your house, or when you buy a property, a house you purchase might cost $800,000, but you'll end up paying, $1 million, let's say $350,000. Before you own it, because you have to pay it over time, right? You take money from the bank today, and then you pay the back over time. A TV might cost $2,000 to buy today, or $3,000 if you buy it on your credit card, right? Because on your credit card, and take a year to pay it back, right? So it's like this is all about the idea that, just think about human psychology, right? I mean, you should look this up, but there's a wonderful experiment called the marshmallow experiment, where what they do is they take a kid and they put a kid in a room with a marshmallow, and they say, you can eat this marshmallow if you want it, or if you can wait 5 minutes and not eat it, we'll give you a second marshmallow. And obviously it's hilarious to watch the footage of the kids doing the task, right? The things they try to do to stop themselves and so on. But the experiment has predicted a lot of interesting things about those kids' futures by their ability to delay gratification. And this is the idea with interest, that if you invest your money today, you give up some money today, but you're better off in your future. If you borrow money to improve your life today, your future gets worse, right? Now, of course, sometimes not all borrowing is bad. I don't want to give you the wrong impression. Not many people have enough money saved up to buy a house that they can do it without borrowing from the bank. However, you should note that when you borrow money from the bank is called a mortgage, and normally mortgage rates are like 3% to 5%. per year that you pay back, right? Now, a credit card, right, which, let's say you're using a credit card, borrowing money from a credit card company is a loan, and your interest there is often like 19 to 29%. Now, you maybe haven't studied this enough yet to understand why these two are as different as they are, but trust me when I say that, and you're entering, this goes back to what we were talking about with the coronavirus, right? That exponential growth is extremely powerful. And as you'll see in this unit, exponential growth changes everything about how we understand our money to work. And I would go so far as to say that the world is divided into two types of people on this topic, which is the people who comprehend exponential growth and try to take advantage of it, versus the people who are at its mercy. Okay, and everyone has to confront this in their lives. Everyone borrows money. Everyone has some money to invest or save for the future. Everyone is going to have to deal with this at some point. Now, the irony that you get 45 minutes of a video of your entire high school career of someone trying to teach this to you is really unfortunate. And if there's more time somehow, obviously not for your evaluation, but just for your own interest, I would love to share more of this with you. But for now, I just want to make sure you have the fundamentals. And of course, if you're interested or you have questions or you want to know more, I'm happy to go there with you. Whatever you want to know about this topic. I think spending time thinking about this is important, especially at your age, because there's such a long time horizon in front of you that you can really take advantage of this if you learn this stuff well. So what I'm going to do here today is I'm going to introduce to you the concept of a TVM calculator. And to do this, I'm just going to Google TVM calculator, and the one I want is financialcalculator.com. Yeah, this is it. Okay, now there's an app on your phone that has this exact icon that I think it's called, sorry, I'll just call it up here. I have it on mine because I taught this last semester. It's called Financial Calculator, and it has that exact picture, and you can grab it on your phone, or you can just use it on this website, financialcalculator.com, right? And then it goes here, and the very first thing to click is TVM calculator. Okay, so that you want to use this. Just believe me when I say you want to use this. Now, let's put the advanced version on. The TVM calculator involves several different fields that relate to different things about your questions. Okay, and basically the concept is, so a TVM calculator requires input in every box except one, and then you can have the calculator solve that box. Okay, so that's what these buttons here on the side do. They solve whatever box you're looking for. So let's hypothesize a question. Okay, let's say I want to know how much money I would need to invest today so that in 30 years I can have $1 million. Okay, just a silly example, but let's go with it. So how much would I need to invest today to have $1 million in 30 years? And let's just make some assumptions here. Assume you can get, let's say 6% on the stock market per year, and which I think is actually conservative. The stock market's historical return, let's just quickly, historical return of S&P 500. What is the average annual return? Yeah, I mean, it's even higher than that, right? So if you just dump your money into the S&P 500 and forget about it, at the last 100 years or so, it's returned about 10%. So whatever, let's go with 6%. Just be a little more conservative. So how much money would I need to invest today to have $1 million in 30 years? Okay, so let's talk about some concepts now from the TVM calculator. Okay, so first of all, it says present value. Present value. Now, present value, okay, is the concept of money today, right? Present value means money today. A negative value means you are giving up money today, i.e., investing. A positive value means you are gaining money today, probably because you are taking a loan. Now, a lot of people mix this up. They think positive is investing because investing is a positive thing, and negative is loaning because they think loaning is a negative thing. But try to understand that positive and negative means gaining money and losing money. If you're investing, you are giving up that money right now that you could use for something else, right? Of course, the future value, right? When we go, let's just take this over to the next column, which would be future value. So in future value, that is money in the future. Now, if future value is negative, that means you are paying back, like i.e. a loan. If it's positive, it means you are gaining money, i.e. an investment. So you can see that it's not that loans are negative or positive. It's that present value and future value need to balance one another. If I am giving up money today, it means I'm gaining money in the future. On the other hand, if I borrow money today, it means I'm paying it back or I'm losing it in the future, right? So that's what the positive and the negatives mean. So in our example, it says I want to have $1 million in 30 years. So I'm going to say for future value 1,000,000, and I'm going to leave it as positive because I want to gain that money. I don't want to lose it. Okay. Now, when it says payments, we're going to come back to this. But just payments, again, it follows the same rule. A negative would means you are investing money regularly, whereas positive means you are withdrawing money regularly. Okay, so in our case, we are not doing anything regularly. It just says how much would I need to invest today. So my payment is 0. I'm not making any payments. Okay, now my annual rate is equal to the interest earned per annum, which means per year. Okay, so in our case, let's just assume we get 6%, like I said before. So I'm going to put 6 as the rate, and that is annually. Now, under here, I'll talk about this in a minute. So we'll talk about compounding periods. Okay, this is how often interest is calculated on your investment. So, for example, if you invest $1,000 at 5%, right? 1 year later, you make 5% of the $1,000. 1 year after that, you make 5% of the original $1,000 plus 5% of the interest you made. And that is the idea of compounding, right? That you make interest on the interest. Now again, it doesn't seem like very much money, 5% of 5%, except that over time it can make a very big difference. In any case, for ours, let's just assume compounding periods. We're just going to leave it as annually for now. Okay? Again, periods we're not touching because that has to do with payments, and we'll come back to it. Oh, I'm sorry, I misunderstood this. The compounding is down here, so we're just going to set this to annually, which annually just means once per year. Now, periods, annual rate interest earned per year. Almost every question is annually for this. It is here for us to change, but we almost never change it. Periods, when it says periods, that means how long are you investing for? And the periods, the frequency, like the drop-down thing for periods, is how frequently do you make a payment? How frequently do you make a payment? Now, in our question, we're not using a payment, so the frequency thing we can just ignore. The periods, though, I need to put 30 because it's 30 years. So I'm going to set it to 30 and annually because that's how many years I'm going to use. So how frequently do you make a payment? How are you measuring the periods, like years, months, etc.? Okay, so again, in our question, we are investing for 30 years. I want to make sure I don't say 30 months, because 30 months would be a very different answer, right? I'm investing for 30 years. It's compounding once a year, and the rate is 6%. So how much money would I need today? By the way, at the top here, end or beginning, you just always have it on end. We don't even need to do that. So when I click PV, what it tells me is that I would need to give, in my question here, I would need to have $174,000 today so that I could invest it, and in 30 years it would be worth $1 million. Now again, if you think about this, this is almost like 5 times as much money, right? Just for letting it sit there. Let's say we go with the S&P's recorded track record, which they said was between 10 and 11%. So let's put 10.5%. How much money do we need? We need 50 grand, right? 50 grand today is $1 million when you're before you're 50 years old, right? So this is the idea of the time value of money and how powerful it can be. Let's do the same thing. Okay, except this time, let's say I have no money. I have no money right now. I can't invest anything. What I want to know is how much would I invest each year for the next 30 years in order to have the $1 million when I'm done. So this time I'm going to leave payment, a present value is 0, and I'm going to click payment. And this is what this tells me. If I could save $12,000 per year for the next 30 years, I'll have $1 million at the end. Which is kind of interesting because $12,000 itself times 30 years is only $360,000, and yet I end up with $1 million. This is the idea of compound interest and the time value of money. Okay, so this is sort of like how all this stuff works. Let's go and try some of the questions that we have now. So it says, again, this question is simple interest. I'm really not interested in simple interest. Simple interest, again, let's ignore simple interest. Okay, again, ignore, not important, not important. You know what? I'm gonna get what I used with my other class. Just a second. Okay, so this box is what I use for my my other class, and I'm just going to use this with you because I think this is just the easiest way to organize this. So this one says find the amount of each loan. $800 at 4% per annum, compounded annually for 3 years. Okay, mode we always set to end. You never change mode. It's up at the top of the financial calculator. It's always end. It doesn't matter. Okay, now present value. Now it's a loan, which means I'm borrowing $800 today, so present value is positive $800. Payment is 0 because there's no regular payment in this question. It just says $800. I just borrowed $800 and I have to pay it back in 3 years. It doesn't say I kept borrowing or that I paid it back in little pieces. I just paid it back all at once. The future value is what we're trying to solve, so I'm going to write the word solve there. The annual rate is 4. Now the periods, okay? It's 3 years, compounding once per year, which is 3 periods. And again, the compounding number here would be 1 because it's per year, compounded annually. Let's talk about compounding numbers for a second. Yeah, so let's just make a chart of compounding numbers. So if the question says annually, semi-annually, let me just go through the other ones quickly. So quarterly, monthly, bi-monthly, no, sorry, semi-monthly, bi-weekly, weekly, and daily. So these are all the different ways that money can be compounded. There are more, of course, but these are the typical ones. Okay, now annually is once a year, semi-annually is twice a year, quarterly is 4 times a year, monthly is 12 times a year, semi-monthly is twice a month, which would be 24 times a year, bi-weekly is every other week, which would be 26 times a year, weekly is 52 times a year, and daily is 365 times a year. Okay, so that's when I say compounding value, I just mean use this chart. Right, so what does the question say? Our question says annually. So the number of years times the compounding value gives me 3, which means the periods is 3. So I'm going to go back to my calculator. I'm going to say the payments is 0, the present value is 800, the future value is unknown, but it's 3 years. The future value is what we're going to solve. The annual rate is 4%, so I put a 4 there, and it's for 3 years, compounding annually. So my future value, how much would I owe in the future? I would owe $899.89, right? So when I solve this one, I get $899, and it's negative. And the reason it's negative is because you're going to owe that money back. You're not going to gain that money in the future. It is negative to show that that money must be repaid. Okay, and that's the way I think is best to approach this kind of work. You just use this and sorry, losing track of where I am, to solve anything. Okay, let's try another one. So I borrow $32,000. So again, mode is end. Present value is $32,000 because I gained that money today. There's no payment. My future value is what I'm trying to solve. The annual rate is 6.5%. It's 4 years, but it's compounded semi-annually. I go back up to my chart. Semi-annually is 2. So I'm interested in this number here, the 2. 4 years times 2 is 8 periods. Okay, so this is what I'm going to put into the calculator. 32,000, 8 periods, solve the future value, a rate of 6.5% per year. Okay, so I borrowed $32,000. It is 6.5% for 8 periods of being semi-annually, and the compounding, what did the compounding say? Semi-annually. Okay, and that's that. I would owe $41,000, 330.48. So I'm just going to copy that number. Now it copies it with the comma, which it's okay for our notes, but if you're using it to put into D2L, you don't keep the comma. Okay, so again, I've gained $32,000 today, but 4 years from now, I'm going to owe $41,330.48. Now, how is this actually working? Let's just look at how this would work for a sec. The concept is a geometric series, right? So let's look at what the geometric series is, right? The geometric series is a r to the power of n minus 1. Sorry. Like that. Okay? That's what we're doing. A is the initial amount. Oops. Is 32,000. R, okay. Now here's where it gets a little bit tricky. When you're doing financial math, you should have the formula should be a little bit expanded. Okay, it should look like, and you have seen this before when we were doing exponential growth. What happens is you have let's see if I can write this down properly. R is equal to 1 plus the interest rate, okay, which I'm going to call I, because it's a 6.5% interest rate, but the interest is you don't multiply by 0.065 because that's going to reduce your money, right? 1.065 causes you to grow by that amount. Do you remember it might be easier actually if we look at this from the perspective of the exponential equation. Let's go back to the exponential equation for a sec. we used to say that this was true, right? 1 plus r to the power of t, right? And this type of math, it really is the same thing, right? It's exponential growth, where NO is your present value. So let's call this future value, is your present value, okay? 1 plus the rate divided by the compounding number to the power of t times the compounding number. Okay, so like that. And what would this look like if we were doing it by hand? This question would be, the present value is 32,000. Then we do 1 plus 0.065, because it's 6.5% interest. We have to write it as a decimal, divided by 2 to the power of 4 times 2. So it would look like that, right? So your future value would be 32,000, 1.0325 to the power of 8. Now when you do that, so again, I'm just going to make a quick sequence. 32,000, 1 plus 0.065 over 2 to the power of 2 to the power of n, where n goes from 1 to 8. Okay, so how much would you owe after 8 terms? You would owe 41,330.48. This sequence, this is a geometric sequence, right? It shows you how much you would owe every half a year. So right now, right, half a year later, and then a year later, half a year after that, 2 years later, half a year after that, half a year, and then 4 years after that, right, is the 41,330.48. So that's where like that's what this machine or this app is doing for you. It's just doing exponential, a geometric sequence or exponential growth, which are really just the same thing. Okay, and that's what it gives you for an answer. Let's try one more loan. Okay, so again, I'm just going to copy paste my box. I'll make the box available for you too if you want to, or you can just just get in the habit of making it. But it isn't that hard to keep track of this stuff. You just put it in the calculator as you go. Okay, mode, end, present value. Okay, I'm borrowing $1,300. The interest rate is 3.75%. It's monthly for 5 years. 5 years, monthly is 12 times per year. So you get 5 times 12 is 60 periods, right? 60 months. The payment, I'm not making any regular payment. I'd like to know how much I'm going to owe at the end of 5 years. Okay, so let's go back and we're going to just put in what we know into this. So I'm borrowing $1,300. The rate is 3.75%. The number of periods is 60, and that is monthly. And the compounding is also monthly. And in the future, I would owe $1,567.64. Okay? Okay, let's keep going. Let's answer a couple more. Yeah, because I want to do the second part of the lesson today too. You'll find the second part is where this tech really benefits you. Okay, Joe borrowed $9,500 for 3 years at 11.6% per annum, compounded quarterly. How much did he owe the bank? Okay, well, again, let's just quickly grab our box here, and we'll answer the question. Okay, again, it's end. How much did he borrow? He borrowed $9,500. The rate was 11.6. It was compounded quarterly, so 3 years times 4 quarters per year gives me 12 periods total. So that should be highlighted. This should be removed. How much will he owe in the future? It's just a matter of typing all that in and finding it out. So 9,500, 12, periods I should replace with 12. Okay, so let's just again just put in what we know into the calculator. Move this over. Okay, so present value is 9,500. Payment again is still 0. We're not working with payments yet. Future value is what I want to solve. Annual rate was, what was it? Sorry, 11.6, and that was quarterly. And the number of periods was 12, which is also quarterly. And it's compounded quarterly. Sorry. This is... Sorry. I understand. Annual, I'm not used to using it with this. Annual rate, we're always going to leave as annually. This one is what we're going to change. Yeah, there we go. That makes more sense. Okay, so it compounds quarterly. It's 12 periods, quarterly. The annual rate is annually, which it basically is for every question. This almost would never change. And your future value is 1338777. Okay, so that's how much he'll owe the bank. How much interest did he end up paying? So interest, easy formula. Absolute value of future value minus absolute value of present value, right? And actually, I'm just thinking... Let's add plus n times PMT, where PMT is the payment. Okay, what does this mean? Your future value subtract your present value and your payment times the number of times you made the payment. So money can't come out of thin air, right? If he borrowed $9,500 and he has to pay back $1,387, $13,387, the rest of it must have been interest. Now, for right now, for our question, we don't have a payment yet. So the future value, he owes this much. He only borrowed this much, and there was zero. Sorry, that should be subtraction. Payments. So I'm just going to put a 0 there. I'm really doing this just for where we're about to go. You don't need it yet. Okay, so we get the answer that, he just have to subtract the 2. So 1338777 minus 9,500, 388777 in interest. Right. So all you need to do is you need to think of interest as like whatever money didn't come from you, right? Or didn't, whatever the difference is between what you actually put in and what you got out has to be the interest. And that's all this formula means. Okay, now present value, a lot of questions work differently where you know the future value. What you want to know is the present value. So I have a goal I want to reach in the future. How much would I need today in order to, reach that goal? So for example, let's say I wanted to have $8,000 in 3 years. And I wanted, and it was invested at such and such a rate and so on. Okay, so again, end is the same thing. Present value, we don't know. Payment is 0. Future value, we know, is positive 8,000 because I want to have $8,000 in 3 years. 5.4 is my rate, and it's 3 years semi-annually, which makes 6 periods. Okay, so what I'm trying to do here is figure out how much money I would need so that I could have $8,000 in the future. So I'm going to replace present value with blank. I'm going to payments is still blank because we're not using that yet. Future value is $8,000. Annual rate is 5.4. Again, it's annually always for that one. Periods is 6, which is semi-annually, and the compounding is also semi-annually. Okay? I'm curious. I want to just test something actually. If I change this, does it? Yeah, it does. Okay, so I don't want to do that. Yeah, okay. So this one. What does this mean? 681816. Okay, this means I would need to give up, i.e. invest, 6818.16 today in order to have 8,000 in 3 years' time. And again, what I'm going to say here is in order to gain. Now, technically, it's always your money all along, right? But the reason one sign is positive and negative is the idea that when you give it up to invest it, you can't use it for anything else. Whereas when you gain it at the end of the process, you could use it for something else. So that's why it's a positive. Okay? Again, I think you get the idea. I don't know that we need to. Let's skip that one and we'll just go to this last one because I still want to do the annuities part. It says Joe is looking to have $10,000 in 5 years. Okay? So again, let's just wipe this out. I just want to make sure I didn't. I did. Okay. He's looking to have $10,000 in 5 years. So present value, we don't know. We're going to solve. Payment is not being used. Future value is 10 grand. Should he invest in a plan that pays 6.3% compounded quarterly or 6.25% compounded monthly? All right, so let's test. One of them has a higher interest rate but a lower frequency of compounding. Which one ends up being better? So 5 years. Let's do the quarterly one first. So 5 years times 4 is 20 periods. Okay, so if we do this with 20 periods, what we're going to have is the future value is 10 grand. The annual rate is 6.3. That's an annual rate. The periods are 20 and it's quarterly. And the compounding is quarterly. So he would need $7,315.83 in order to get his $10,000 that way. Now the other way is he lowers the interest rate a little bit to 6.25, but it's compounded monthly this time. So it's 5 years, but this time it's compounded 12 times per year, so it compounds a total of 60 times. And instead of bolding the 4, I'll bold the 12. Okay, so once again, we're just going to take all the same assumptions into the calculator. We're going to change this to 6.25. We're going to change this to 60 and monthly. And we're going to change this to monthly. And how much would he need? 7322.09. So he needs slightly less money, right? He only needs $315 as opposed to $322 if he goes with the first option. So he should go with the first option since he needs less money today to achieve the same goal. Okay, that is the lesson on compound interest. I'm going to go ahead and talk about annuities because this is, I think, where it really gets interesting. Again, if you're out of time for today, you can pause and come back, but just while we're on this topic, I'm just going to finish it off. Now, an annuity is a much more realistic scenario for most people. Because, if I want to buy a house, I'm probably not going to be able to save up enough money to buy the house in one shot, right? Or if I could, that would mean I'm living, on the where am I living for the 30 years while I'm saving up the money, right? I mean, it just doesn't really work. So an annuity is the concept of I'm not borrowing $800,000 from the bank today to pay them back $1.2 million in one big chunk in 30 years' time. I'm paying because, of course, why would they count on me to do that? Instead, I'm paying them back every couple of weeks, right? A few $100s every couple of weeks, and over a long course of time, eventually I'll pay them back, right? And this is where the concept of an annuity comes in, which you can think of as a geometric series where we are adding up a series of compounding terms over and over. There's a great diagram in your textbook for this. I don't think we have it in the notes. Let me pause and see if I can pull it up. Okay, so again, just a Google image search. Imagine you invested $1,000 at 5%, but you kept doing it year after year. Where would you be in 5 years? Now, your original $1,000 would have compounded 5 times. Your second $1,000 would have compounded 4 times, and 3 times, and 2 times, and once, and so on. So the idea of an annuity is I'm not investing $1,000 once and then just leaving it there for 5 years. Rather, I'm contributing to it over and over again. And of course, each one of these would require a separate compound interest calculation, which, if you're doing this for 30 years, can be pretty obnoxious to do. Right? So the reason we come up with the annuity formula is for how to solve this situation where you're doing it for many, many years without doing the compound interest over and over and over again. Of course, if you look at this, this is a geometric series. A is 1,000, R is 1.05, and the number of terms is, 5, right? And you could use your addition formula to add all these up and get that same number, right? So, of course, I don't think it's super important to invest a lot of time in that when we have a perfectly good tool that'll do the work for us, right? So we'll just use the tool. It says, Chi, sorry if I'm not pronouncing that right, puts away $500 every 3 months. So look, as soon as you see this, it's not a one-time payment. Not a one-time payment. Okay, like PV was. This is a repeating payment. So it goes in the PMT column or box in our calculator. So let's look at the box again. So use the same box for this. This is the advantage of doing it this way. Okay, so let's use the box. And okay. So, she puts away $500 every 3 months at 5.2% compounded quarterly. Now, of course, every 3 months is just another way of saying quarterly, right? Because that would happen 4 times a year. So that means quarterly. So let's write down what we know. 5.2 is the rate. It's compounded quarterly. So my compounding number is a 4. Okay? So my compounding value is a 4. How much will her annuity be worth in 25 years? So 25 years times 4 quarters per year is 100 periods. So it's 100 periods. The future value is what we're solving. The present value is 0 because it doesn't say she has any money to start with. Right? She's putting away 500 every 3 months. So we're going to make a payment of negative 500. Okay, because again, negative because she is investing it so that the future value can be positive. Okay, so this is what we have. So we just need to use the calculator and we'll solve it. Okay, so mode is set to end. Present value is 0. She has no money today. She is investing $500 every quarter for 100 quarters. Okay, or 100 periods. She's getting 5.2% as an annual interest rate, because every question is annual interest rate. And the future value is what we want to know. Do you want to take a second and pause it and guess? If you saved up $500 100 times, how much would you predict you would have? So think about it. She is saving $500 times 100 quarters. So she's going to have 50, right? 500, and then 2 more zeros. So $50,000 of her own money invested, right? And this is what I was talking about before when I said N times PMT. This is N times PMT because N is 100 periods times 500 per period. So that's what that formula I was just talking about earlier means. So she saves of this money, whatever she's about to get, $50,000 is what she put in. Okay, let's see how much she actually gets. $101,487.91. So despite the fact that only 50 grand of it is her own money, right? She actually has $100,000, right? And so here's where I was talking before about the interest, right? So the interest, let's just use that interest formula one more time, is FV minus PV minus N PMT, which in our case would be 101,487.91 minus 50,000, which is 51,487.91 in interest. So more than half of the money in there is money the bank gave her, right? Not her own money. Okay? So this would be minus 0 because she has no PV. Okay? So this is the kind of thing I'm talking about where people will not reliably predict this correctly. I wouldn't be able to predict this correctly. I can solve it, but I understand that my intuition, my gut feeling of what number this should have come up here really has no basis in reality. I just don't know, right? And many people don't know. And they don't understand that buying something today on a credit card might end up costing double the amount of money by the time they pay it off. Is that television really worth double its price just to get it today, right? Okay, let's try another one. Sam wants to make monthly deposits into an account that guarantees 9.6% interest compounded. Sorry, I'm just going to grab our box here so I can fill in as we go. Okay. Wants to make monthly deposits into an account that guarantees 9.6% interest compounded monthly. So let's get monthly highlighted. Let's change our compounding value to 12. He would like to have $500,000 in that account at the end of 30 years. So 30 years times 12 compounding is 360 periods. So 360 months from now, which is 30 years from now, he wants to have, this is what we're going to solve. Again, I'm going to put present value as 0 because he has nothing to invest today. He's just going to invest at the end of the month, right? So he doesn't have a lump sum that he's starting with. Okay? The future value that he wants to have is 500,000, and the future value is positive, which means we can predict that the payment is going to be negative because he's saving the money over time. Let's fill in what we know. 9.6 is the annual rate. 360 is the number of months, and it's monthly. It's compounded monthly. The future value he's interested in is 500,000. The amount he would need to save each month is $240. Again, ask someone on the street, ask anyone you know. At 10% interest in 30 years, if I invested every month, how much would I need to put in each month in order to get $500,000? If they're even thinking this much, 50,000 divided by 360 periods, right? I want $500,000, and I'm dividing and I'm putting it in once a month. If I was going to do this all with my own money, right? If there's no interest in the question, then I would need to do 500,000. I would need to put in $1,388, 1,388.89 per month if there's no interest. But I actually only have to put in 240, right? Which is like a fifth of what that is. So again, our intuition, our sense of the right answer is just not going to be right here. We are not good at making these calculations or having a gut feeling about these calculations. Okay, Len borrowed $200,000 from the bank to purchase a yacht. Okay, so present value, he gained that money, 200, he gained that money today. That's why it's positive. Remember, PV positive for a loan, since you gain money now. Okay, the bank charges 6.6% compounded monthly. He will take 20 years to pay off the loan. Okay, so 20 years, monthly, 240 periods, 240. The bank is charging him 6.6% per year, and Now here's an interesting thing. Right now, we don't know the payment, which is obviously what we need to solve in this question. Solve, because it says how much will each monthly payment be. Let's fill in what we know. So payments, what we're solving, present value 200,000, future value we don't know, 6.6 annually, 240 monthly. Now, if I click payment here, right, and then I click future value, what is it doing? So I want you to understand something about paying back a loan. When you're paying back a loan, this is the scenario you will always see. Present value, future value, payment. The present value is positive since you are borrowing that money right now. The payment is negative since you are repaying the debt over at regular intervals. The future value. What is the future value of paying back a loan? The question is, how much will you owe when you're done paying? And the answer, of course, is 0. So when you're paying back a loan, future value is 0 because the idea is you've used all these payments to reduce your loan down to 0. Okay? So when you see PV positive, FV0, PMT negative, you should recognize that person is paying back a loan. They gained a bunch of money today so that they will have nothing in the future because they're paying it back regularly over time. Okay? And if you solve this one, so let's go back and we'll make the future value 0 and we'll solve for the payment, we get 1502.94. Okay? And it's negative because he has to pay that back. Now, of course, the future value, if you calculate it here, it says $2.06 because this is rounded, right? Really, he would have to pay some decimal in the payment, but you know, we're going to ignore that for what we're doing right now. You could solve it, but you don't need to. So you can round it to a number of cents. Okay, so he would have to pay $1,502.94 each month for 240 months to repay this loan. By the way, if you do n times PMT, right, what's 240 times that number? 1502.94. He ends up paying $367.05.6 for his yacht. Right? A yacht that, of course, he gets the benefit of using the object for the 20 years, right? But monetarily, he's paid almost double the object's worth by the time he's paid it off, right? Now, of course, again, sometimes that's still a good idea. If you need to live in a house, and you do need to live somewhere, then this can be a sensible way to borrow a lot of money and pay for a house or pay for a condo, right? But I would say a luxury item or an item that isn't a necessity, you probably don't want to be doing this. Okay, so we already answered that question. So how much interest he would have paid is, $367.05. So again, interest is always the same. Interest equals FV, the absolute value, minus that, minus n PMT. And in this case, interest would be the future value, which was 360 minus how much he borrowed, which is 200,000, which is $160,000 in interest. Let's do one more. Actually, sorry. Let's do an assignment question. First, before I do that though, I want to just give you the basic scenarios of what you would be putting into this calculator, what all the different scenarios would mean. Okay, so let's do one table where we go PV. So let's start with one PMT equals 0. FV equals positive, FV equals negative, PV equals positive, PV equals negative. In a situation where future value is positive and present value is positive and payment is 0, this cannot exist. Because this would be like borrowing today and then gaining in the future. You can't do that. Just like this one, this would be cannot exist. Losing today and continuing to lose in the future. Make sure I understand this right before I say this. This isn't the way I was thinking of organizing it, but anyway. Okay, here, investing money today to gain in the future. No payments. Borrowing money today to repay in the future. No regular payments. Okay, so this is what the first part of the lesson was about, where there was no payments. So if PMT is equal to 0, right? So that's what this. Let's shade it. So if PMT is equal to 0, this is what you get. Okay, so you can recognize the different situations. Let's try another one. What if FV is 0? Okay, so PV could be positive or negative. PMT could be positive or negative. Okay, if you borrowed money today, so sorry, PV is positive means you borrowed money today. PMT positive means borrow money at regular intervals. PMT negative means invest at regular intervals. Okay, now, is it possible that you could borrow money today, continue to borrow more money at regular intervals? Let's put it like this, right? Future value will be negative since you have borrowed, and since all you've done is borrow. Okay, future value will be negative in this scenario. Okay, what would happen in this scenario? Present value is positive, payment is negative. In this one, future value will be 0 since you are repaying the loan. Okay, and that's, if you ever see a question that's repaying a loan, you immediately know what to do. Future value is 0, payment is whatever they're paying, present value is, whatever they borrowed. Okay, let's do the last two. If present value is negative and payment is positive, that means you invested a large sum or a sum of money and are taking it out a piece at a time. There are two common scenarios for this. One of them is a lottery winner, one of them is a retiree. Right? So a person who wins the lottery, a smart thing for them to do would be to invest the money and then withdraw it in little pieces, and they will go much, much farther, as you'll see. A retiree is another person. They save up money while they're working, and then they take it out a little piece at a time, and they draw it down to 0. Again, future value equals 0 here, since eventually the money runs out. Right? So a person who saves for their retirement, eventually they run out of money. A person who wins the lottery, eventually they run out of money. The idea would be, how much could I take out, or how long could I make it last? This last one is future value will be positive since you made an investment today and keep adding to it in the future. Okay, so this chart will basically help you answer any annuities question that you might get. Okay, and it depending on what sign you use, you would be matching it to a different scenario. So let's take a quick look at the assignment. Okay, so I like asking this question. A person's using a financial calculator, enters the following. Which situation is it? So PV's negative, PMT's positive, future value is 0. Okay, PV's negative, PMT's positive, future value is 0. This is a lottery winner or a retiree. Okay, a person who saved $100,000 and starts withdrawing $2,000 a month. Right, so again, there's a couple of these ones, but just to get you used to the scenarios, they're there. Okay, let's try this lottery question. So let's just copy paste it for now. Okay, a person wins the lottery of $2,750,000. They invest the winning at 6% interest annually, compounded every day. The person wants the prize to last for 40 years. How much will the person be able to withdraw every day? Okay, so let's use our chart and let's answer it. Okay, mode is end because mode is always end. Present value. They are going to invest 275,000. They're going to invest that today. So they win the lottery, but they're not going to use the money. They're going to invest it instead. They get 6% interest. It's compounded daily, and they want it to last for 40 years. Okay, so 40 times 365, 14600. Okay, so that's how many periods there are, because there are 14,600 days in the next 40 years. By the way, if they were, let's just see how much they would have if they took it out regularly. So 50. So imagine they just took out the same amount every day without any interest in the question. Then they would have, sorry, I just don't want it to be a, oh sorry, it's under algebra. Okay, so they could take out $188.36 per day. So if there was no interest, they could take out 275,000 divided by 14600, which is 188.36 per day. So it doesn't really seem like, I mean, obviously $100 a day would be really nice for anybody, but it doesn't seem that big. $200 a day. I guess it is. It's still a lot of money, but it doesn't seem like, it seems like you could easily spend that. You know what I mean? So 275, anyway, so 2.75 million divided by 14,600, that's how much they would get per day if there was no interest in the equation. So let's figure out with interest. Our compounding period was 365, so we're going to put daily, 14,600 periods, 6 annual rate, $2,750,000 is the present value. And the future value is going to be 0 because eventually, after 40 years, they want the prize to run out, right? So they want to use it all up in the 40 years is the idea. So let's type it in. Present value, negative 275,000. Payments we don't know. Future value is 0. Annual rate is 6. Periods is 600. And that's daily and compounds daily. So how much could they take out each day? They could take out $497.17 each day. So you see, if you win, I mean, obviously it's not really about winning the lottery, it's about your retirement eventually. You can make the money last a long time if you take it out a little bit at a time, right? And if you keep it invested and you keep it earning money for you, then you can withdraw, right? A lot more of it over time. In our scenario, the person's prize is actually worth, right? They had 14,600 days to spend it, and $497.17 per day, right? So $497.17 times E. the prize was actually worth 7,200,725. Let's just put approximately so you don't watch me copy these decimals. Or almost triple their, well, not maybe not almost triple, but more than double. Okay, and this is how you can use the calculator to simplify the questions I'm asking you. So the question, to go back to this, it said the person wants the prize. How much will the person be able to withdraw each day? We said 497.17 was the number, right? 497.17. Okay. Okay, so again, my first question I know I got right is I recognize the scenario. And my question down here, right, again, just use the calculator and you'll be able to do it as well. If you have any questions about this, of course, feel free to ask. And if you're interested in learning more about this, feel free to ask that as well. I'm happy to discuss.